Welcome back to CircuitMeter Insights, the podcast where energy meets intelligence. Discovering how smart analytics, real-time data, and cutting-edge efficiency solutions are driving the future of sustainability forward. So, plug in, power up, and let's dive in.
Welcome to the Deep Dive. You're here because you want to cut through all that information noise and, well, get right to the knowledge that really matters. Today, we are doing a critical deep dive into the tech that's actually powering the shift to net zero. We're talking energy intelligence. And the core mission, it sounds simple enough, making energy visible so we can finally manage it properly. Now, if you're part of an enterprise trying to hit those, serious ESG targets, you probably know the frustration I'm talking about. You want to manage your energy use, but for decades, the existing metering technology, well, it's made getting comprehensive data really complex, slow, and just prohibitively expensive. We've got some sources here that lay out these really deep-rooted industry challenges, the kind of roadblocks that can stop net zero strategies dead in their tracks. And interestingly, they also detail a surprisingly effective solution, one that's completely resetting the standard, it seems.
That's exactly right. For years, companies had this strategic ambition, right, to be more efficient, prove compliance, but is constantly undermined by, well, technological debt. The tools available just weren't built for the internet age, not really, or for true enterprise scale. So our mission today is kind of twofold. First, we need to unpack the hidden costs, the fundamental technical limits that kept real-time energy intelligence out of reach for most businesses. And then we're going to look at how one company, CircuitMeter, basically decided to toss out the old playbook. They used creative, sort of out-of-the-box IoT thinking to tackle those exact barriers.
Okay, so let's unpack this then. Where did this status quo, this old way, start to fail? Like even before companies could get the first meter installed?
Yeah, it really boils down to accessibility, mostly driven by cost and complexity. You might budget for the meter itself, sure, but these legacy systems, they have this compounding cost effect. You're paying high prices, not just for the meter hardware, but the complex installation labor, all the necessary extra gear. We're talking specialized PCs, programming tools, software licenses. It all adds up. And then you imagine you have a huge campus or multiple sites. Trying to scale that kind of system, it turns an investment into, well, a potentially crippling capital expenditure.
And I think we often just glance over the sheer difficulty, the misery maybe, of the installation process itself. That feeds right back into the cost, doesn't it?
Absolutely. Traditional metering is incredibly labor-intensive. So many different physical parts need to be wired and configured. Right away, that limits how many points you can realistically afford to meter. You might want data from every single circuit breaker, but the cost and time involved quickly forces you to only measure, say, the main feeds or large equipment loads. And then there's the training issue, which adds another layer of inefficiency. The sources point out that the electrician often needs to learn a specific, sometimes complex application just to program one vendor's meter.
Right. And what happens if something goes wrong during that already complex setup, which, let's be honest, probably happens quite a bit?
Oh, that's the real budget killer. Say the current transformers, the CTs, those clamps measuring the current, or maybe the phase alignment, if that's installed incorrectly. Well, the data you get is instantly garbage, useless. But fixing it, that means the installer has to physically go back to the site, sometimes hours away. They have to manually correct the wiring or the configuration. That time sink, that extra truck roll, it just destroys any hope of a quick ROI.
So even if you manage to get through the installation nightmare, the actual strategic value was still hampered by the software platform itself.
Correct. These systems often started life as PC-based applications. That limits them from the get-go. They were mainly designed for electrical engineers, so the reports. Often very technical, hard to customize for, say, a CFO or an ESG manager who needs clear, actionable business insights. Data storage was often quite limited too. And the whole architecture, fundamentally, just wasn't built to handle energy management across an entire corporate portfolio, which is exactly what's needed for any serious net zero strategy today. What's really fascinating here is when you look closely, the underlying technology, the core architecture, it was just fundamentally unsuited for what we need now. Real-time, large-scale data collection. The tech itself was actually fighting against the goal.
We often talk about communication protocols like Modbus as just, dry technical details, but it sounds like they were a major bottleneck, the thing stopping large-scale intelligence from ever being truly real-time.
That's exactly where things hit a hard ceiling. Let's look at the basics. Communication efficiency, for instance. Legacy systems often relied on TCP/IP. Now, TCP/IP is reliable, yes, but it uses significantly more overhead compared to protocols like UDP. That makes it slower, and it eats up a lot more network bandwidth. But the real sort of structural flaw was the widespread use of Modbus.
Which our sources pretty bluntly describe as very old technology. What is it about Modbus specifically that makes it such a roadblock for, like, enterprise-scale deployment?
Well, it's inherent in the protocol itself. Modbus uses a master-slave communication structure. The main system, the host, acts as the master.
Yeah.
And it has to actively ask every single device, the slaves, one by one, hey, give me your data. This process, called polling, is incredibly inefficient. It's costly to scale up because the master gets busier and busier, and it introduces significant delays or latency in getting the data. But here's the real killer, the strategic flaw. Modbus is inherently limited. It can only handle, at most, 247 devices on a single network segment.
Wait, hang on. 247. If you're talking about a major commercial building or an industrial site with hundreds of circuits or a corporation with, say, dozens of facilities, 247 devices per network is basically a guaranteed roadblock. You can't get comprehensive metering like that.
It's a dead end, exactly. If you truly want to measure energy consumption across your entire factory floor down to the machine level, you're going to hit that 2047 limit almost immediately. It forces you into complex network segmentation, or more likely, you just give up on the goal of fully granular, visible energy data. And remember that inefficient polling mechanism we mentioned. It also suffers from huge latency issues. It's impossible to truly synchronize the data coming from all those different points simultaneously. If you want real-time control, real-time decision-making based on energy use, you need synchronized data. Polling just can't deliver that reliably at scale.
Okay, and then if we layer modern IT requirements, especially security, onto this sort of creaking legacy architecture, that must have created another major headache.
Oh, absolutely. A huge one. Traditional systems often relied on having a web server, maybe even on the meter or a local controller. This frequently required opening inbound firewall ports. Why? So the master system sitting somewhere else could pull the meters through the firewall. Any IT security manager listening will tell you immediately, opening inbound ports like that is a massive security risk. It's basically leaving a door open, a vulnerability waiting to be exploited.
Okay, here's where it gets really interesting then. CircuitMeter looked at all of that. The high costs, the installation complexity, the slow polling, that 247 device bottleneck, the security flaws. And instead of just trying to tweak the old tech, they essentially said, let's start over, using modern IoT principles.
That's the key. Their core product is actually quite elegant. The WebMeter 48. It's an IoT smart meter designed to handle up to 48 separate inputs that could be 48 electrical circuits or pulse inputs from other meters like water or gas. And it achieves incredibly high accuracy ANSI C12.20 class 0.2, which is revenue grade. Built tough too, supports up to 600-volt systems so it works in heavy industrial settings. But like you said, the hardware is only part of it. The really big innovation is in how it communicates. It flips the whole philosophy.
Right, so they stopped the master system constantly asking for data, and instead...
Exactly, they started listening. Instead of inefficient polling, the WebMeter itself uses a proprietary, very high-speed UDP communication protocol to actively push data out to the cloud platform. Think of polling like a teacher calling role, asking each student individually if they're present. It takes time, right? Pushing is more like each student just instantly reporting here the moment they arrive. The device itself tells the platform when new data is ready. This supports synchronized, genuinely real-time data across every single metering point almost instantaneously.
Okay, so that switch from polling to pushing tackles the speed and the efficiency problem head-on. But what about those huge security risks of the old way, the open firewall ports? How did they get around that?
By reversing the data flow direction. Since the meters are the ones initiating the communication, pushing data outbound to the cloud, there is absolutely no need to open any inbound firewall ports. None. This makes it cybersecure by design. It immediately solves one of the biggest headaches for corporate IT departments trying to deploy operational technology. And the data itself. It's protected end-to-end using AES 256 encryption. The communications channel uses SHA 256 authentication. We're talking the same kind of robust security standards used in modern online banking.
Wow, okay, so security and speed, that's the foundation. But accessibility and scale were those other massive failures of the legacy systems. Did CircuitMeter manage to solve the limited data storage problem too?
Completely. Yeah, the platform provides true real-time data. You can see updates every 2 seconds, typically for a rolling 24-hour window. But crucially, it also stores vast amounts of historical data. We're talking 15-minute interval data going back a full 10 years. And this isn't just dumped somewhere. It's managed by a proprietary big data engine designed for speed. So when you need to run a complex query, say, comparing energy use across 50 buildings over the last 5 years, you get a response almost instantly, not waiting hours for a report to generate.
And because it's built as a global platform on a proper internet foundation, it means it's accessible from anywhere, right?
Just using a web browser, supporting unlimited users, teams, multiple buildings.
Exactly. That is the definition of true enterprise scale that was just impossible with the old PC-based site-limited systems.
Right. So let's bring this all together now. Thinking about the strategic impact for a business.
Yeah.
If we synthesize these benefits, this shift really seems to move energy management away from being just a reactive sort of niche engineering task and turns it into a proactive business intelligence tool. Is that fair to say? Absolutely. And the impact on the total cost of ownership is, well, it's pretty revolutionary. Where the legacy systems piled up costs hardware, software, labor, auxiliary gear, CircuitMeter focuses on achieving the lowest cost per metering point. How? By drastically simplifying the installation and configuration and eliminating the need for all that expensive extra equipment on site.
Okay, let's talk about those installation nightmares again. How specifically does this new architecture address the need for complex on-site programming by the electrician and those incredibly costly return visits to fix errors?
This is probably one of the smartest parts of the design, really. Installation is simplified down to basically 2 steps. Mount the WebMeter device and clamp the CTs around the wires. That's it physically. All the configurations, setting up circuits, naming them, and crucially, fixing any phase alignment errors if the CT is put on backwards. That's all handled through remote configuration and remote software corrections via the cloud platform after the physical install is done. The electrician on site doesn't need specialized software training. They just do the wiring. And if a mistake is made, like a reversed CT, it gets flagged and corrected remotely in seconds by someone back at the office, not by sending an electrician back out for hours. This means deployment is incredibly fast, and it massively slashes those hidden soft costs associated with installation problems.
That capability alone sounds like it would dramatically shorten the payback period for companies investing in this kind of granular metering.
Precisely. It removes a huge amount of friction and unpredictable cost from the process. And the architecture itself is inherently built for the future. The global platform scales easily because it was designed from day one on an IoT, internet-based foundation. Remember how updating firmware on old meters used to require an expensive, time-consuming site visit for each device? Now, all firmware updates are handled securely via remote WebMeter software updates pushed from the cloud. Keeps the system secure, adds new features, all without disrupting operations or needing a truck roll.
And finally, that user experience transformation. You're replacing those often clunky, limited PC applications with a modern web-based global platform. It gives you potentially 10 years of historical data immediately accessible, visually presented, and it's designed for the business user, the energy manager, the sustainability team, not just the electrical engineer, right?
Exactly. Our sources mention companies reviewing it as the best and easiest to use platform they've seen. It provides deep, actionable data through an intuitive interface, plus an API for real-time integration if needed. So fundamentally, by embracing this secure, push-based IoT architecture, CircuitMeter managed to break those core barriers, cost and complexity. They effectively transformed energy data acquisition. It went from being this complicated, often unreliable engineering headache into an affordable, instantly scalable source of genuine business intelligence. And this is how organizations can actually start proving and, more importantly, accelerating their progress towards net zero goals.
So what does this all really mean for you listening right now? Well, the ability to actually measure energy consumption right down to the individual circuit or machine level and do it quickly, affordably, and securely, it completely changes the conversation around energy. It shifts the focus away from just basic compliance reporting towards active, verifiable energy management, which is pretty much the essential infrastructure needed to actually achieve modern ESG targets. And here's a final thought for you to maybe chew on based on what we've discussed. Given those hard physical limitations of older tech like Modbus, remember that 247 device limit per network, and the really significant security vulnerabilities that came with needing to open firewall ports. Just how many major commercial buildings, how many industrial sites across the country, or even the continent, do you think are currently operating effectively blind when it comes to their energy use? How much waste, how much unrealized savings potential is still out there simply because making that technological leap to a secure, truly scalable solution seemed too difficult or too expensive in the past? Something to think about. Thanks for diving in with us today. We'll catch you on the next deep dive.
And that's it for this episode of CircuitMeter Insights. We hope this discussion has powered up your understanding of how smart analytics, real-time data, and cutting-edge efficiency are transforming the energy landscape and driving the future of sustainability forward.